So, last topic ma wave optics, Hygiene's principle and interference. So, considered to be very tough topic ma. చాలా మంది లెక్చరర్స్ చెప్పారు ఇది ఎట్లా అర్థం కాదు పిల్లలకి, బట్ వీ విల్ ట్రై టు మేక్ ఇట్ వెరీ సింపుల్. ఓకే, see my wavefront. What is meant by wavefront? So write down source of light emits radiations in all directions. Okay ma? So the locus of all points which are in the same phase, is called wavefront. Clear ma? So the locus of all the points which are present in the same phase is called as wavefront. Is it clear? See, my any source of light, for example, you take any point source of light. So it will be emitting radiations in every direction. No? So it will be emitting radiations like this also, like this also, like this also. So light is traveling in the form of waves. We know that light travels in the form of waves only. No? Clear no? Now, if I take the locus of all those points, locus means what? The joining of all those points which are present in the same phase, then it is called as wavefront. Let us try to understand this one. Sima, consider this is a source of light. So this source of light, let us suppose it is giving 2 waves. Okay, similarly in this direction also, let us suppose 2 waves. Clear? డయాగ్రామ్స్ రావడానికి ఇవన్నీ చాలా కష్టం ప్రభా, గీయడం అన్ని వేవ్స్ ఒకే విధంగానే రావాలి. 1 2. క్లియర్ మా? సో ఇన్ దిస్ డైరెక్షన్ ఆల్సో 1 2 waves. క్లియర్ మా? సో 1 2 waves. So 1 2 1 2 waves. Consider like this. Okay, now see my, if I take a waveform appears like this. No? Clear? So this is 0. What is this phase? 90 degrees. No? Now see, so here the angle made by the waveform is 90 degrees. No? This one is how much? 180. This one 270, and this one is 360 degrees. Clear? No? Now how many waveforms I have drawn? 1 2 3 4 5 6 waveforms I have drawn. Okay, now you take all those points which are present at 90 degrees. Okay, so this is the point where 90 is present in this wave. Clear no ma? Red color marker red bendre. Okay, similarly in this wave also you take, this is the point where 90 degrees is present. Similarly here it is 90, here it is 90. So here it is 90, here it is 90. Clear no ma? So you join all those points which are present at 90 degrees. Then a sphere will be formed. No? So that spherical surface is nothing but wavefront. Are you able to understand? That sphere which is formed, this gives radiations in every direction. No? So therefore a sphere will be formed. So if you take every point on the sphere, then every point will be having 90 degrees. That is called as a wavefront. Are you able to understand? Similarly after 90, if you take 180, then I will get another sphere. No? That is also a wavefront. Similarly you take 270, I will get one more sphere. That is also a wavefront. Now how many waves I have drawn? 2 waves I have drawn. Two waves I have drawn, no? Clear? Two waves. So after two waves, what is the total angle covered? ठीक है जी, काउंट करते हैं, बोलो जल्दी. After two waves, what is the total angle covered? बोलो जी. 720 up to here 360. Now after two waves it is 720. 360 plus 360. क्या करें बोलो टिफिन? White rice खाए दे? Let's just खाए. Okay, ba? So after this two waves I have drawn, no? So therefore, if you take all these points, then all these points they are making how much angle? 720. So all of them are at the same phase, no? So you join all these points. Okay, ma? Then this forms a wavefront. So that is the definition of a wavefront. Are you able to understand, ma? So on the wavefront, every wave will be present at the same phase. Then the locus of all those points, that is the surface of all those points, is called as wavefront. Okay, right on. Okay, ma'am. So next we discuss about types of wavefronts. See, ma'am, consider this is a point source of light. What is this one? Point source. Give an example of point source of light. Sun. Laser light. Mamul bulb point source of light is na. You have 60 watts, 100 watts bulbs, no, incandescent bulbs. They are point sources of light. Clear? See, point sources of light, they emit what kind of wavefronts? They give spherical wavefronts. What kind of wavefronts they will produce, ma? Spherical wavefronts. So, point sources, they give spherical wavefronts. Spherical wavefronts means what? In the form of a sphere. Okay? Because they give radiation in every direction, no? So total locus will be just like a sphere. So spherical wavefronts will be formed. Clear? Similarly, if you take this tube light, so this is cylindrical source of light. Tube light is a cylinder, no, ma? Tube light is what kind of body? Cylindrical body. Then the type of wavefront formed here is cylindrical wavefronts will be formed. This type of wavefront will be formed. Okay, ma? And above this one more wavefront, one more wavefront, one more wavefront, like this. Many wavefronts can be formed. So therefore, cylindrical sources, they form cylindrical wavefronts. Okay. Now, the point which we should understand here is that spherical wavefronts, after traveling a very large distance, clear, no? Note point is that spherical wavefronts after traveling large distances, okay, ma? tend to become plane wavefronts. Okay. Now let us see what is the meaning of this SIMA. For example, this is point source. So this gives wavefronts in every direction, no? Clear, no? So like this kind of wavefronts will be formed. This kind of wavefronts will be formed. Clear, no? Okay. Now can you say what is the difference between this first wavefront and the last wavefront? Size. Wow. Okay. Radius. Usa size bhi kati ji. Okay. See, here the nature of the curve is very large, you know, here, and here by the time it reached to the last position, flatness of the curve has increased, you know, flatness has increased. For example, if you take this small length here, you can find a lot of curvature. Clear? No? But if you go to the last wavefront, if you take the same distance, it is behaving like a plane wavefront. straight line wavefront. Are you able to understand? So point source of light, at the initial stages it is spherical only. But when these spherical wavefronts, when they travel to a large distance, then it tends to become more and more flatter. So it behaves like a what you called plane wavefront. Plane wavefront in the sense, so wavefronts, they will become like this after some time. Straight lines. So this is one wavefront. All the points are in one phase. This is next wavefront, next wavefront, next wavefront. Okay. Give an example of plane wavefront. Example of plane wavefront. Chapandi. Sunlight is a very good example. What is the reason? Sun is present at a very large distance. No? So sun produces spherical wavefronts only. But by the time they reach the surface of Earth, they become more and more flatter. Very large distances, there are no lakhs of kilometers is there. So these wavefronts, they become flatter, 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 and finally when it reaches Earth, we get a flat wavefront. We get a plane wavefront. Are you able to understand? So this is the point which you should understand. So spherical wavefronts, after traveling very large distances, they become plane wavefront. Okay. And next we define a ray of light, by which we study ray optics. In ray optics, what we have studied reflection, refraction, all this we have studied, Nama. That was possible because of ray of light. So what is meant by ray of light, we will study here. A ray of light means what? Okay. So it is a line perpendicular to wavefront. Okay. So it indicates direction of energy flow. It indicates direction of energy flow. This is called as ray of light. Okay. Now see here, these are the wavefronts, no? So to these wavefronts, if I draw a perpendicular line like this, then what this perpendicular line indicates? Can you say? This is the direction in which energy is flowing, no? So this is called as a ray of light. Ray of light. Are you able to understand? Actually, light travels in the form of wavefronts. But we have taken a ray of light and we studied ray optics, no? So what is meant by ray, that we are discussing here. Ray means that direction of energy flow which is perpendicular to the wavefronts. So this is one ray of light. This is another ray of light. This is another ray of light. So these are the rays of light. So they indicate what? They indicate the direction of energy flow. Okay? That's it. Now similarly in plane wavefronts also, what is the direction of energy flow? This is the direction of energy flow. This is the ray of light. Clear, ma? Okay? Sima. So Hygiene's wave propagation. So Hygiene said that, clear, ma? Every wavefront, every point on a wavefront, it behaves like a secondary wavefront. So what is the meaning of this? See here. So this is a point source of light. Okay. So this produces a wavefront. No? Now he says that every point on this wavefront, it behaves like a secondary source of light. Wavefront painunna prati point malli secondary source laga behaves. That's Hygiene's theory. So this behaves like a source of secondary wavefront. This one, this one, this one. It means from here I can draw one more small wavefront. From here I can draw one more small wavefront. From here I can draw one more small wavefront, one more small wavefront. Are you able to understand? No? And now you take the locus of the secondary wavefronts. So like this. Then it forms another wavefront. That theory is called as Hygiene's theory. Are you able to understand? So this theory we will use in understanding some of the concepts which are upcoming. So you need to understand what he said. So every point on the wavefront, it behaves like a source of secondary wavefront. Now you take the locus of all those points. Then again you will get another wavefront. And on the next wavefront also, every source behaves like again a point source of light, like this. Like that you can go on constructing the wavefronts. That is Hygiene's theory. Okay, ma? So see. So principle of superposition says that when two waves meet at a point, then the resultant amplitude is the vector sum of individual amplitudes. So I can write y dash is equals to y1 dash plus y2 dash. I can write like this. What is the meaning of this sigma? So consider two waves are traveling randomly in any direction, whether both waves are traveling in same direction or opposite direction, whatever it may be. So consider this is first wave. Okay, ma? Consider it is traveling in this direction. So what is the amplitude of this wave? Amplitude of this wave is y1 dash. Y1 dash. Clear, ma? And in the same direction or in opposite direction, there is one more wave which is traveling like this. Okay. Now the amplitude of second wave is y2 dash. Clear, no? So like this, when two waves, when they meet at any point, then what happens? The resultant amplitude, it will be the vector sum of these two amplitudes. Now here, both amplitudes, they are in same direction, no? Both crest and crest, they are superposing, no? This is called as crest, this is called as trough. Crest and crest are superposing, no? So resultant amplitude will be how much? It will be the sum of these two amplitudes. It means resultant amplitude will be this much. This will be my resultant amplitude. Are you able to understand? So this total amplitude will be how much? It will be y1 plus y2. That's it. This is called as superposition principle. Now what is this kind of superposition? This is called constructive superposition. Constructive means crest superposing on crest, trough superposing on trough. So resultant amplitude will be very large. Now this kind of superposition is also possible, no? So this is one wave, and consider this is the second wave. Okay? So one wave is traveling like this, consider second wave is traveling like this. Are you able to understand, ma? Now what is happening here, can you see? Crest is superposing on trough. Clear, no, ma? And crest is superposing on trough. Now can you say, how can I draw the resultant amplitude? How can I draw the resultant amplitude here? You have to subtract, that's it, no? So consider this is y1, ma? And consider this is y2. Y1, y2, are they equal? No, which one is bigger? Y2 is bigger, no? So therefore what will be my resultant? Y2 minus y1 will be my resultant. Understood, no? So therefore here will I get a positive pulse or negative pulse? Negative pulse. Why I will get negative pulse? Chappandi. Y2 is bigger than y1, no? So my resultant will be, this will be my resultant. Okay? So what is this resultant? This is y2 minus y1. Like this. Understood, Amma? So this is constructive superposition. This one is destructive superposition. And when amplitudes are equal, then resultant will be 0 also. Are you able to understand? Now here can you say what is the phase difference? Phase difference is how much? Can you say, anybody? Here what is the phase difference? Here what is the phase difference between two waves? Chappandi. In a wave, we know phases, no, ma? Okay, so this is 0, this is 90, this is 180, this is 270, this is 360. Clear? Now can you say what is the phase difference between these two waves? Chappandi. వాడండి కొంచెం టిఫిన్ తిన్న తర్వాత కూడా అట్టే ఉంటారా కాసేపు phase difference between these two waves is how much? 0 is the phase difference. Why 0 is the phase difference? Crest is superposing on crest, no, ma? Crest is superposing on crest. There is no phase difference. So when phase difference is 0, it is called constructive superposition. You can remember like this also. Okay, ma? So therefore what I write? When phase difference is, phase means what? Powder eskunde phase kaadu. Phase ante angle. Angle covered by the wave is called phase, PHASE, phase. So phase difference, if it is 0 or multiples of 360, then waves superpose constructively. Okay, ma? Constructive interference or constructive superposition will happen. Understood? No? Now here what can I write? Can you say what is the phase difference here? 180 is the phase difference. 180 degrees is the phase difference. What is the reason? So this is crest. This is trough. So from here to here it is 180. From here to here it is 360. 360 minus 180, 180. So phase difference between both of them is 180 degrees. Understood, Nama? So therefore, if waves superpose at phase difference of 180 or 360 plus 180, like this if you go on. 180, 360 plus 180, 360 plus 360 plus 180, 360 plus 360 plus 360 into 180, like that. Phase difference must be 180. See, my phase difference is 360, it means 0 only, no? Phase difference 360 undante meaning emi? 0. Okay? So difference should be how much? 180. So therefore 180 అందుకే ఎక్కువ ఆవేశంతో టీచ్ చేయకూడదు అనేది. ఆవేశం కొంచెం ఉంటే చాలు. Sima. Are you able to understand? So phase difference if it is 180 or 360 plus 180. 360 value is 0, no? So 0 plus 180 again 180. So 180, 360 plus 180, 360 plus 360 plus 180, like this. In this multiples, if waves interfere, then they will have destructive superposition. Clear, Nama? 180 or 360 plus 180, then waves interfere destructively, or waves superpose destructively. Okay? Make a note. Okay, ma? Now see. So, next we are studying about interference, ma. So, interference is also a type of superposition only. What is meant by superposition? We study any two waves, no? Whatever waves, they are traveling in any direction. When they come into contact with each other, then what becomes the amplitude of the resultant wave? That is called as superposition. Now, interference means I want to observe this superposition effect on a screen. Are you able to understand, ma? I want to study when two waves interfere, then what is the pattern that I can observe on a screen? So if I want to observe superposition on a screen, then I need interference. Are you able to understand? And interference is not possible with any two types of light sources. For example, Sima, this is a source of light, this is a source of light. Okay? So are these two interfering? Lights may be superposing. But interference effect you cannot see. What is the reason? Interference effect means what? Formation of bright band, followed by dark band, followed by bright band, followed by dark band. That observation on a screen is called as interference. So these two lights also, they are interfering. They are superposing. But pattern I cannot see. What can be the reason? These two lights also, they are waves only, no? So wave of this light and wave of this light, they will superpose. Are you able to understand, ma? But that pattern I cannot see. I cannot see that here white light is formed, next dark band is formed. That we cannot see. What is the reason? Because these two light sources of light, they are coming from different sources, no? So their amplitude, their frequency, their phase difference, it will be changing continuously. In which condition light will be emitted? Light will be emitted when electron goes to higher orbit. Already we have studied, no? When electron goes to higher orbit, again it returns to the ground state, then light will be emitted. Okay? So in this light, electron goes to higher orbit at a different time. In this light, electron goes to higher orbit at a different time. So phase difference is not constant. So therefore, even though superposition is there, pattern you cannot observe. Okay? So therefore, what I require coherent sources of light. Coherent source of light means what? That sources of light which is having same frequency, same amplitude, and a constant phase difference or zero phase difference. Okay? Can you say from where can I get such kind of lights? అటువంటి లైట్స్ నాకు ఎక్కడ దొరుకుతాయి చెప్పండి. In both the sources of light, electron should go to the higher orbit at the same time. How it is possible? Anybody? Can you say? ఆలోచించి చెప్పండి. Very good. But I want two sources of light. ఒకటి మూనా? అబ్బా, ఇంకొక సన్నాన్ని చూస్తుందిరా. దాన్నే నీట్గా ఎక్స్ప్లెయిన్ చేయండి. సీమా, I want to, Sima, for interference or superposition should happen, two waves should be there, no? One wave should be coming from one source of light, another wave should be coming from another source of light. So in both the sources of light, amplitude should be same, frequency should be same, phase difference should be zero, or constant phase difference should be maintained. How it is possible? అసలు ఇటువంటి రెండు సోర్సెస్ పాసిబుల్ అవుతాయా? ఇట్ ఈస్ ఇంపాసిబుల్. సో వాట్ ఐ విల్ డూ? No, what I will do is, we take a single source of light. We take a single source and make two sources from it. Are you able to understand, ma? I will take a single source of light and I will make it such that two lights are coming from the same source. Now it is possible, no? See here. For example, this is a single source of light. So this will be emitting wavefronts like this, no? Emitting wavefronts like this. So I will take a cardboard. Here you make a small hole, and here also you make a small hole. Now here light is falling from the same source, no? So, and these are holes. So here a wavefront will come and fall on these holes, no? In Hygiene's principle, what we have studied, every point on the wavefront behaves like a secondary source of light. That's what we have studied, no? On a wavefront, if you take, every point on wavefront behaves like another source of light. So therefore, here one wavefront will be incident, no, on these holes also. So from here again, another wavefronts, they start emerging outside. Okay, ma? So this also behaves like a secondary source of light. Okay. Now this is one source of light, this is one source of light. Now can I call these two sources of light to be coherent sources? Why? Because they are coming from same source of light, no? They are coming from same source of light. Definitely their amplitude, their frequency, their phase difference, everything should be constant. Okay? So this is the method of taking coherent sources of light. And once I take a coherent sources of light, so for example, you take on a screen. Okay, ma? So the light from this wave and light from this wave, if they meet here, always they will meet with same constant phase difference. ఈ రెండు సోర్సెస్ నుంచి వెళ్ళిన లైట్ ఇక్కడ మీట్ అయింది అనుకోండి, దెన్ వాట్ ఎవర్ amplitude is, whatever phase difference is present between these two, that is always maintained constant. So therefore here if a dark band is present, if they are interfering destructively, always they will interfere destructively only. Okay, ma? Similarly, if light reaches this point from these two sources, and here if two waves are interfering constructively, then always you will find constructive interference only. Are you able to understand, ma? Because phase difference is always maintained constant, no? So here if it is a dark band, always you will find a dark band. Here if it is a bright band, always you will find a bright band. So that is how we observe this interference pattern, and the concept is same, superposition principle only. Are you able to understand, ma? So here if waves are meeting at a phase angle of 0, then it is constructive interference. Here if sources of light are meeting at an angle of 180 degrees, phase difference of 180, then it is destructive. And always they reach the same point with the same phase difference, because both of them they are coming from same source of light. Are you able to understand, ma? Then I can observe this pattern which is called as interference pattern on a screen. Understood now? Right. See, ma. So in interference, we study about constructive interference and destructive interference, ma. Red color marker red bandra. See, ma, here. So these are two sources of light, coherent sources. Okay. Now if you take these two sources of light, and here if you take point O, point O is at same distance from S1 and S2, no, ma? It is exactly at the middle of the screen. Okay. So this point O, it is at same distance from S1, it is at same distance from S2. Distance same kada? So therefore what do you understand? If distance is same, what do you understand? Sima, from here to here, if 3 waves will reach, from here to here also 3 waves only will reach, no? Are you able to understand? Because what kind of sources we are taking? Coherent sources? No, see. So from this source up to here, this point, 1 wave, 2 waves, 3 waves. 3 waves have reached, no? Now from this point again to the point O, this source. So 1, 2, 3. Okay? If 3 waves are reaching from source S1 and source S2, then again what do you understand? ఇప్పుడేం అర్థమైంది మీకు? సేమ్ అయితేనే కొహెరెంట్ అంటాం దాటిని. ఇంకా ఏం అర్థం కాలేదా? Sima, from S1 and S2, 3 waves are reaching. From here also 3 waves, from here also 3 waves. What do you understand? Phase difference is 0 between them. Because 3 waves. After 3 waves, what is the phase difference? 3 into 360. For first source. For second source also, 3 into 360. So 3 into 360 minus 3 into 360? 0. So there is no phase difference. If there is no phase difference, how they will interfere? Constructive interference. So see here, trough is superposing on trough. Clear, Nama? So this is the trough from S1, this is the trough from S2. So trough and trough are superposing, no? If trough and trough are superposing, it is called constructive interference. So you will get a bright band or a dark band. Huh? You will get a bright band. This is the bright band you will get. Clear, Nama? So in the screen, you will find a very bright colored band. Band means a path, a space. Clear, ma? Now you see the second point. This is point O, no? Let us take point P. Okay, ma? Now see, ma, point P, is it equidistant from S1 and S2? S1 ki S2 ki okay distance lo unda adi? It is nearer to which source? S1. It is farther away from S2. So definitely I can say that same number of waves will not reach, no? Okay, ma? From here if 3 waves will reach, from here 4 waves may reach. Now see how many waves are reaching? 1, 2, 3, 3.5. 3.5 waves are reaching. Okay? Now from S2, 1, 2, 3, 4 waves are reaching. Are you able to understand, ma? So from S1, 3.5 waves are reaching. From S2, 4 waves are reaching. So what do you understand? There is a phase difference of 180 degrees. Half wave is extra, no? Half wave means how much phase difference? 180 phase difference. So between this source and this source, at this point, there will be a phase difference of 180 degrees. And when waves interfere at 180, what kind of interference? Destructive interference. Clear, Nama? So therefore here, the band which is formed is dark band. Dark band will be formed. Are you able to understand, ma? So like this, continuously you can see a bright band, a dark band, a bright band, a dark band on up the screen and down the screen. Screen paina kinda itla meeku bands form avutu veltayi. Is it clear, ma? That's it. Okay. So this is called as constructive interference and destructive interference. Okay. Now let us name these waves also. Now see. So next we are studying about path difference and phase difference. Path difference and phase difference. So what is meant by path difference, ma? Path difference means difference in distance traveled by the sources of light. That is called as path difference. So path difference, how can I calculate? Path difference delta x is equals to S2p minus S1. Just I can calculate like this. Path difference ante mani difference between distance traveled by each source of light. So For S2, so light from S2 is traveling how much distance? S2. Light from S1 is traveling S1p. So S2p minus S1p will become the path difference. Now can you say what is meant by phase difference? Phase difference means difference in angle covered. Now can you say what is the difference in angle covered? 180 degrees. That's all, no? So how can I calculate delta pi? So see the first one, 4 into 360 minus 3.5 into 360. If you do this calculation, then it is 180 degrees. Clear, no? And mathematically, how can I represent? I can represent delta pi is equals to 2 pi by lambda multiplied by delta x. Very, very, very important equation. Many times questions were given on this equation. So relation between phase difference and path difference. 2 pi by lambda multiplied by delta x. Delta x is nothing but path difference. Delta pi is nothing but phase difference. Clear? So like this you can relate path difference and phase difference. అర్థమవుతుంది కదా? path difference అంటే distance traveled, phase difference అంటే angle covered by both the sources in reaching that point. Okay? That's it. See, ma'am. So next we are studying about Young's double slit experiment, Thomas Young's double slit experiment. This experiment proved the wave nature of light. So this experiment proved that light is traveling in the form of waves. It proved wave nature of light. Okay, see here. So this is one source of light. This source of light is made to pass through 2 holes from a cardboard. Okay, ma? Then these 2 sources, they behave like secondary sources, no? And they behave like coherent sources also, because both of them, they are coming from same source of light. Now see here. Now this thick line indicates crest. Light travels in the form of crest and troughs, no? So this is crest and dotted line indicates a trough. Now see how they are interfering. See here, if you look carefully, see here, crest and crest, they are superposing, no? Trough and trough are superposing. Crest and crest, trough and trough, crest and crest, trough and trough. What do you understand? Ala ravali diagram. Huh? Phase difference is 0, no? Crest is superposing on crest, trough is superposing on trough. This is constructive interference. Constructive interference only, no? So therefore, the light which travels in this direction, in which direction? In this direction. Clear, Nama? So it goes and hits the screen here. Clear? Are you able to understand, no? So I am passing the line through which points? Wherever I find a crest and crest, they are superposing, trough and trough are superposing, I am drawing a straight line. Then I see that here at the center of the screen, a bright band will be formed. Bright band. Okay, ma? Why bright band has formed here? Bright band enduku form ayindi cheppandi? Constructive interference, no? Crest has superposed on trough. Crest has superposed on trough, crest only. Trough has superposed on trough only. Now you see the next one. Now see this one, man. So here, crest and trough, they are superposing, no? Crest and trough, crest and trough, crest and trough, crest and trough, crest and trough. Okay? So if you join all of them, so diagram may not be perfect, but still we will try. Like this. Clear? So this is a point where continuously crest and trough, they are meeting at an angle of 180 degrees. Phase difference is how much? 180 degrees. Okay? So therefore immediately here you will find a dark band. Center of the dark band. Clear, ma? Actually dark bands will not be like this, but for your understanding I am saying. Okay? So this is a dark band. Dark band in the sense here you don't find any light. Clear? Similarly, see the next one. So trough and trough, crest and crest, trough and trough, crest and crest, trough and trough, like this. So therefore, if I draw this line, this is the line I will get. So here I will find a bright band. Clear, ma? So this is a bright band. Clear, no? Similarly, crest and trough, crest and trough, crest and trough, crest and trough. here I will find a dark band. Okay, but diagram may not be perfect, but I hope you can understand. So this is a dark band. Okay, ma? So therefore, this experiment proves that light always travels in the form of waves, and they superpose or interfere to continuously form bright bands as well as dark bands. Are you able to understand? Okay. Now, width of SIMA. Now here we have to study some parameters. What is this distance? This distance is called distance between the slits, no? Small d. Small d is called what? Distance between holes or distance between slits. Okay? And this distance from the source to the screen, this distance is called capital D. Okay, ma? Holes madhyalo distance undi kada, adi vachesi small d. And distance between screen and the sources of light, it is capital D. Are you able to understand? Therefore, width of each fringe, there are some calculations, I am not writing. Width of each fringe is equals to lambda d by d, which is called as beta also. Okay, ma? So what is the width of bright fringe or what is the width of dark fringe? Both fringes. Both fringes, they have same width, no? Clear, no? So width of bright fringe and width of dark fringe, lambda d by d. Are you able to understand? It means that, SIMA, if you take this distance, center of the screen to the next bright band, this distance is called as beta. Okay? So this is the center of the screen, no? Where first bright band is formed. Next bright band is at how much distance? Next bright band is at a distance of beta. That is also called width of the band. Are you able to understand? Ma? And its value is how much? Its value is lambda d by d. Okay. Similarly, now can you say what is this distance? Ma? Distance between two dark bands or width of a dark band, same. So this is also beta is equals to lambda d by d. Clear? Now answer my question. So distance of first dark band from center of the screen is how much? Can you say? Half beta. Clear, ma? So from this is the central bright band, no? From the central bright band, first dark band, this is the first dark band. Dark band will be at how much distance? Exactly half of beta. Okay? So therefore it is a half of or lambda d by 2 into small d. So like this you can go on calculating. You will get a fourth bright band at how much distance? Sixth dark band at how much distance? Like this you can continuously do the calculation. Are you able to understand? Now some more questions. Distance of fourth bright band from center. Can you say? Distance of fourth bright band from center. Fourth bright band. आके अंदर से हंसता हूँ. कहीं कहीं जी कर रहे हैं. First bright band lambda d by d. Fourth bright band 4 into lambda d by d. అది కాదు నేను చెప్పింది. అదే నన్ను అనింది. సరే ఓకేనా? సో దిస్ ఈజ్ ఈక్వల్స్ టు 4 into lambda d by d. That's it. ఓకేమా? క్యాల్కులేట్ డిస్టెన్స్ ఆఫ్ ఫోర్త్ డార్క్ బ్యాండ్ చేయండి. డిస్టెన్స్ ఆఫ్ ఫోర్త్ డార్క్ బ్యాండ్. ఆలోచించే రోజు బోల్తీ ఆలోచించండి. డిస్టెన్స్ ఆఫ్ ఫోర్త్ బ్యాండ్ ఫ్రమ్ సెంటర్ ఆఫ్ ద స్క్రీన్. ఫోర్త్ బ్యాండ్ చించండి రా కొంచెం. 3.5 times of beta. That's it. Clear nama? See ma here, from center to first dark band, it is half beta, no? This total distance is beta, but first dark band will get at half beta, and from that second one beta, third one another beta, fourth one another beta, beta plus beta, beta plus beta plus beta by 2. That's all. Artham kaledu? Arthamaindi? Artham kaledu. Very good. So what is the distance between center of the screen to first bright band, first dark band? First dark band. What is this distance? Bright ki distance anta? Beta. Bright ki dark ki? Beta by 2. Okay? So this distance is how much? This distance is beta by 2. Understood, Amma? Now from the first one, second one will be at how much distance? Second dark band? Beta. Third one? Beta. Fourth one? Another beta. So beta plus beta plus beta? 3 beta. 3 beta plus beta by 2. That's all. So therefore, 3 beta plus beta by 2. That is the distance of fourth dark band from the center. So we are writing in general terms. There are some equations, panchayat anta undi, adanta em avasram ledhu. Concept netsukondi chalu. Clear nama? So therefore, 3 2s are 6. 6 plus 1, 7 beta by 2. Or you can write 7 by 2 lambda d by t. That is my answer. Understood nama? That's it. Very simple. Okay ma? See ma, this is the intensity distribution curve ma. So at what positions you will get bright bands, at what positions you will get dark bands. Already we have studied, no? That I have drawn in the form of a diagram. Clear? So this is intensity graph. So this is the maximum intensity. At the center you will get a bright band, no? At the center of the screen what you will get? Bright band. Now that brightness decreases and at the center of dark band it is completely dark. See my bands are not like as if we have drawn on the board. ఒక చోట బ్రైట్, ఒక చోట డార్క్, అట్లేమీ రావు. ఇంటెన్సిటీ వ్యారీస్. అట్ ద సెంటర్ ఆఫ్ బ్రైట్ బ్యాండ్ ఇట్ విల్ బి మోర్ బ్రైట్, అట్ ద సెంటర్ ఆఫ్ ద డార్క్ బ్యాండ్ ఇట్ విల్ బి మోర్ డార్క్, అండ్ ఇంటెన్సిటీ వ్యారీస్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? సో దట్ ఈస్ ద గ్రాఫ్ హియర్. సో దిస్ ఈస్ ద సెంటర్ ఆఫ్ ఫస్ట్ బ్రైట్ బ్యాండ్, సెంట్రల్ బ్రైట్ బ్యాండ్, ఇట్ విల్ బి వెరీ బ్రైట్, అండ్ సెంటర్ ఆఫ్ డార్క్ బ్యాండ్ విల్ బి వెరీ డార్క్. సో ఫస్ట్ డార్క్ బ్యాండ్ అట్ హాఫ్ బీటాను, సెకండ్ డార్క్ బ్యాండ్ అట్ half beta plus beta, 3 beta by 2. First bright band at center, second that is next bright band at beta. So if you take this distance as positive, this distance you can take negative. That is the distribution of bright bands and dark bands. Okay? Right. So now we are discussing about mathematical equations of Young's double slit experiment. See here. So we have taken two sources now. Both of them they are coming from same source only, but they are behaving like coherent sources. So they may have some phase difference, they may not have some phase difference, but phase difference will be constant. So wherever they are interfering, always they interfere with same phase difference. That already we have studied. So therefore, let one wave will be equal to, equation of wave is what? A sin omega t. A is the amplitude, and we are taking amplitudes are same. Amplitudes are same. What is meant by amplitude ma? Amplitude same annar baane undi sir, inta amplitude ante endo maaku teliyadu ante. So height of the wave is called amplitude. So this is called as amplitude of a wave. Clear na? So let amplitudes are equal, but they are having some constant phase difference of pi. What is pi here? Pi is the phase difference between first wave and second wave. Are you able to understand now? So therefore, by superposition what I can write? I can write y is equals to y1 plus y2, no? So therefore I will write a sin omega t plus a sin omega t plus pi. Clear ma? And there are some mathematical calculations which I don't want to do. So final answer is 2a cos pi by 2, okay ma, sin omega t plus theta. So this is the resultant wave which you will get. Okay, but derivations are not required. Just you remember the equation. Clear no? So if these two waves interfere, this is the resultant wave which you will get. Is it clear? Now you look at this equation. This equation is like r sin omega t plus pi, no? It means this total value I have written in terms of r. Now can you say what is r here? R ante? R ante man cheppandi. Try to say. This is the equation I got. 2a cos pi by 2 sin omega t plus pi. Now what is 2a cos pi by 2? R gato range kaji. That is the amplitude of the resultant wave. Ikkada a ante mani amplitude, mari ikkada amplitude of resultant wave. Are you able to understand, ma? So therefore I write that what is r here? R is equals to 2a cos pi by 2. This is the amplitude of resultant wave. Clear, ma? Amplitude of resultant wave. Okay, so two waves are superposing and meeting at one point, then the resultant amplitude is given by this equation. Okay, now let us see what is the importance of this equation. Sima, when only one wave is taken, okay ma, second source is closed. So listen very carefully. Now see here, tarvata raskochu, vinandi first. Now in Young's double slit experiment I have taken two sources, no? So what I will do, I will close one source. Now there is only one source. Are you able to understand, ma? Two sources are there. ఒకదాన్ని క్లోజ్ చేసేస్తే ఒకదాని నుంచి వెళ్ళిన లైట్ మాత్రమే స్క్రీన్ పైన పడుతుంది కదా. ఓన్లీ వన్ సోర్స్ గోస్ అండ్ ఫాల్స్ ఆన్ ద స్క్రీన్. దెన్ ఇంటెన్సిటీ ఆఫ్ సింగిల్ వేవ్, intensity of single wave is given by I naught is proportional to amplitude square. This is a very, very important equation. If you are taking a single source of light, then intensity means brightness of the light. Depends on what? It is directly proportional to square of the amplitude of that wave. ఆ వేవ్కి ఎవరి స్క్వేర్ తీసుకోవాలి? యాంప్లిట్యూడ్కి స్క్వేర్ తీసుకోవాలి. ఆర్ ఏబుల్ టు అండర్స్టాండ్? సో లెట్ ఇట్ బి మై ఫస్ట్ ఈక్వేషన్. నౌ ఇఫ్ we take a resultant of two waves, if we take a resultant of two waves, okay, so here also intensity is directly proportional to amplitude square, no? If you take the resultant, then you have to take intensity of the resultant is directly proportional to resultant of the amplitude square of the resultant of amplitude. What is the amplitude I got? 2a cos pi by 2, okay ma? So therefore I will write IR square is directly proportional to 2a cos pi by 2 whole square. Can I write like this? Okay ma? So this is the intensity because of single source of light. This is the intensity of resultant waves when two waves when they are interfering on each other. Clear? So this is my second equation. So divide both of them. So see ma, not IR square, I square. So IR divided by I naught is equals to 4a square cos square pi by 2 divided by a square. That's all. So a square get cancelled. So therefore what is the equation I will get? I will get IR is equals to 4 I naught cos square pi by 2. So this is the equation to calculate intensity of the resultant wave. Intensity of what? Intensity of resultant wave is given by this equation. And what is I naught? Intensity of single wave. That you should not forget. I naught is intensity of single wave or single source of light. Understood? No? Right. Listen. So next we are studying about, this is the resultant intensity we have calculated, no? 4 I naught cos square pi by 2. Now this intensity will become maximum in which condition? This intensity will become minimum in which condition? Cheppandi. Intensity means brightness. Brightness will be maximum in which condition? When it is constructive interference. And the intensity will become 0 when it is destructive interference. Ante kada? So now I want to find out at what phases So this intensity will become constructive, this intensity will become destructive. Okay, see. So IR is equals to 4 I naught cos square pi by 2. So IR maximum intensity is how much? 4 I naught only, no? Maximum intensity 4 I naught. Cos, because maximum value of cos theta is 1 only, no? 1 square. So cos square is also 1 only, no? So maximum intensity is only 4 I naught. So this is possible. This is possible in which condition? If cos square pi by 2 will become 1. That's all, no? When cos square pi by 2 becomes 1, then intensity will become maximum. Yeah, 1 kane ekku undochu kada. Maximum value of cos is 1 only. So antakanna ekkuva raadu. So cos square pi by 2 if it is 1, then cos pi by 2 will be how much? Cos pi by 2 can be plus or minus 1 nama? Because plus 1 into plus 1 is also 1, minus 1 into minus 1 is also 1 only. Now cos pi by 2 will become plus 1 or minus 1 for which angles? So pi by 2. Cos 0? 1. So 0 degrees. Cos 180? Minus 1. So 180 degrees. Okay, ma? So then again 180 plus 180. Then 180 plus 180 plus 180. Okay. So for these angles continuously, cos values will become plus 1, minus 1, plus 1, minus 1. So for every change of 180 degrees, it changes from plus 1 to minus 1. Cos 0 plus 1. Cos 180 minus 1. Cos 2 pi 0 plus 1. Cos 360 plus 180 minus 1. Like this it goes on. Okay. So therefore if I write in general terms, how can I write? Clear, na? So pi by 2 is equals to 0. 180 can be written as pi, no? 2 pi, 3 pi, like this. Okay, ma? So for these angles, or when phase difference is this much, then this is not phase difference, but this is only half of phase difference, no? Phase difference will be how much? Pi is equals to 0, 2 pi, 4 pi, 6 pi, 8 pi, and it goes on like this. So for this phase difference between two waves, interference will be constructed. Are you able to understand? Phase difference should be either 0 or it should be 2 pi, 4 pi, 6 pi, 8 pi, like this. Is it clear, ma? Then our interference will be constructive interference. Now can you say what is meant by phase difference of 2 pi? Phase difference of 2 pi means? Ante mane? What is meant by phase difference between two waves is 2 pi. What is the meaning of it? ఆలోచించి చెప్పండి. ఇంకా చెప్పండి. వాట్ ఈస్ మెంట్ బై ఫేజ్ డిఫరెన్స్ ఆఫ్ 2 pi బిట్వీన్ టూ వేవ్స్? ఇంకో వేవ్, दो वेव्स के बीच में होना चाहिए. व्हाट इज मेंट? ఓకే, ఫేజ్ డిఫరెన్స్ బిట్వీన్ టూ వేవ్స్ ఇస్ 2 pi. ఒక వేవ్ గురించి మాట్లాడడం లేదు నేను. ఇట్ మీన్స్ దట్ దీస్ ఆర్ టూ సోర్సెస్ ఆఫ్ లైట్, నో? సో ఫ్రమ్ హియర్ one wave, two waves are reaching. Okay, so this is one wave, consider this is second wave. And now from the second source, 1, 2, 3 waves are reaching. Now what is the phase difference between them? 2 pi. That is the meaning of it. Are you able to understand? Ma? Phase difference 0 means you take this point. Clear? One wave, two waves. From here also, one wave, two waves. Phase difference is 0. Phase difference is 2 pi means what? One wave is extra for one source of light. Then also interference will be constructive only, because trough and trough only they are superposing, no? So definitely phase difference you can call it as either 2 pi or you can say 0 also. Understood, Nama? So 0, 2 pi, 4 pi, 6 pi, 8 pi. For these phase differences, definitely interference will be constructive interference. Understood, no? What is the meaning of it? 2 waves. From here 2 waves are reaching, from here 4 waves are reaching. Then phase difference will be extra 2 waves, no? So 2 pi plus 2 pi, 4 pi, like that. Understood, Nama? So now you write destructive interference. Destructive interference. Okay. So destructive interference means what? Sima. Resultant intensity 4I0 cos square pi by 2 should become 0. That is called destructive interference. No? Brightness should completely become 0. It means total intensity should become 0. Total intensity can become 0 in which condition? Only when cos square pi by 2 becomes 0. Clear, Nama? So cos square pi by 2 becomes 0 for which angle? For 90, for 270, 270 plus 180, 270 plus 180 plus 180. Okay, ma? So for these angles, phase difference will become, cos value will become 0. Cos 90, 0. Cos 270, 0. 270 plus 180, 0. Like this it goes on. Are you able to understand, ma? So if you write in terms of radians, then how can I write? Pi by 2 is equals to 90 means how much? Pi by 2. 270 means how much? 3 pi by 2, and it goes. Okay, ma? So 270 plus 180 means again 5 pi by 2, na? 5 pi by 2, 7 pi by 2, like this. Okay. So therefore, what is the phase difference? Phase difference is pi, 3 pi, 5 pi, 7 pi. It goes on like this. Are you able to understand? Pi by 2 values are this, pi values will be this, no? Pi 3 pi, 5 pi, 7 pi. So if phase difference is in multiples of pi, then definitely waves will interfere destructively. So you can see dark band present on the screen. Are you able to understand? Now can you say what is meant by phase difference of pi? Phase difference of pi means what? 180 degree phase difference. It means that half wave will be extra, no? So Sima, consider this is one point, this is another point. So 2 waves are reaching. So 1, 2, half wave extra is reaching. So from this source 2 waves are reaching, from this source 2.5 waves are reaching. Therefore crust superposes on trough. Phase difference will be pi. 180 means pi. So wherever you see multiples of pi, 3 pi, 5 pi, 7 pi, then you will see destructive interference. That's it. Are you able to understand? Okay. Okay, ma? Now in this condition of constructive interference, path difference will be how much? Can you see? Path difference will be how much? In constructive I am talking. In constructive interference, if these are the phase differences, path difference will be how much? Chappan. Bolo. Chappan. Phase differences are 0, pi, 4 pi, 6 pi, 8 pi. Path difference? वो भी phase differences होता है वो path difference. Path difference means what? Distance traveled. Distance traveled difference will be how much? Matter just angles lo chepta distances lo cheppu naaku. No. See, my path difference is 0, phase difference 0, path difference also 0, first one. And for the second one, if phase difference is 2 pi, then it means one wave is extra, no? What is the length of one wave? Lambda wavelength. What is called length of one wave? Lambda. Clear, no? Sima, for example, if this is a wave, what is this total distance called? Lambda. Okay? Length of one wave. So if one wave is extra, then phase difference will be 2 pi. Path difference will be lambda. 4 pi means 2 waves are extra. 2 waves are extra means 2 lambdas are extra. So 2 lambda, 3 lambda, like this it goes. Understood, Nama? Now here, in destructive interference, say the path differences. Path difference. Lambda by 2. Lambda by 2. Next time వస్తుంది చెప్పండి. λ/2 ప్లస్ λ/2 వేస్తే ఒక వేవ్ ఎక్స్ట్రా, వన్ వేవ్ ఎక్స్ట్రా. ఒక వేవ్ ఎక్స్ట్రా అయితే కన్స్ట్రక్టివ్ అవుతుంది కదా. అది ఎక్కడి నుంచి వచ్చింది? సో ఆల్వేస్ వీ షుడ్ హ్యావ్ ఎ ఫేజ్ డిఫరెన్స్ ఆఫ్ λ/2, no? So you add one more wave extra. So lambda plus λ/2. Lambda means zero phase difference. Additionally 1 λ/2, 3 λ/2. Like this you go on adding. Okay, ma? So total this much is how much? 3 λ/2, 7 λ/2, like this. 5 λ/2. Understood, ma? These calculations are very, very, very important, ma. వీటిపైన మిమ్మల్ని క్వశ్చన్స్ అడుగుతాడు వాడు. అర్థమవుతుంది కదా? సో లిసన్ వెరీ కేర్ఫుల్. సో అండర్స్టూడ్, నో? సీమా, హియర్ టూ వేవ్స్ ఆర్ రీచింగ్. So what is the total distance traveled? Total distance traveled is 2 lambda, no? Clear, no? But from this source 2.5 waves are reaching. So what is the total distance traveled? 2 lambda plus λ/2. That's all, no? So what is the path difference? This is how much? So 2 lambda plus λ/2 minus 2 lambda. So 2 lambda gets cancelled, λ/2. Understood, no? That is called as path difference. So path difference when is λ/2, it means half wave is extra, then destructive. Lambda plus λ/2, again half wave extra, again destructive. 5 λ/2, lambda plus λ/2, another half wave extra, again destructive. Like this. Are you able to understand? చదివేటప్పుడు ఇట్లా డయాగ్రామ్స్ వేసుకుంటూ చదవాలి మీరు. How many waves are reaching the point? What is the phase difference? What is the path difference? Okay, ma? So previously we studied interference when amplitudes were equal, no? A sin omega t plus pi. Now what we are taking, amplitudes are also different. First one is having amplitude of A, second wave is having an amplitude of B. Amplitudes are also different. Then in this condition, resultant amplitude is given by R is equals to A square plus B square plus 2AB cos pi. This is the equation. Okay, ma? This equation you should remember. Okay, ma? So resultant amplitude, when amplitudes are also different. So R is equals to A square plus B square plus 2AB cos pi. See, when amplitudes were equal, then what was the equation I got? 2A cos pi by 2 I got, no? This is in which condition? When amplitudes, when they were equal. And this is the condition when they are not equal. Okay? Now see. So here again, if I write constructive interference. So constructive interference is possible in which condition? When cos pi becomes plus 1, no? Okay, ma? When cos pi becomes maximum, then resultant will be maximum. Resultant amplitude will be maximum, then it is called constructive. So when cos pi becomes 1, then R value will be how much? It is A square plus B square plus 2AB. Okay? Nothing but, so this is R square, not R. So R square is equals to A plus B whole square. Nothing but R is equal to A plus B. It means just to add their magnitudes, that is my answer. Understood now what is happening? So if phase difference is 0, then constructive interference happens. Are you able to understand? Then cos pi, when it becomes 1, then it is this formula, no? A square plus B square plus 2A. Nothing but R square is equal to A plus B whole square. R is equal to A plus. So here what we are doing, just adding the amplitudes of first wave and second wave, I am getting the resultant amplitude. Are you able to understand? Similarly, destructive, here only I will study intensity. So intensity is directly proportional to R square, or I will write intensity is directly proportional to amplitude square. This already we have written, no? Intensity depends on what? Square of the amplitude. So therefore this total equation, how can I write? Instead of R square, I will write I resultant. Can I write? लिख सकते हैं, कई को लिख सकते हैं, बोलो. Good logic. Clear, ba? So Intensity is directly proportional to amplitude square, no? So here already square is present. So I will write intensity, IR, resultant intensity. So this is equals to, instead of A square, what is A? Amplitude of first wave. So intensity of first wave is I1. Clear, Nama? Intensity of second wave is I2 plus 2. Instead of A? Huh? ఆలోచించండి. రైట్ అతైనారు మీరు. Intensity is directly proportional to amplitude means root I is proportional to amplitude, no? So instead of amplitude, what I have to write? Root I1. Clear, no? So root I1 and amplitude of second wave is root I2 multiplied by cos pi. Okay, ma? So this is the resultant intensity when amplitudes are different. When amplitudes are same, what is the equation we have written? 4I0 cos pi by 2. Cos square pi by 2. Okay, ma? ఇది చదివి మర్చిపోతూ ఉండండి, భలే ఉంటుంది. Okay, ma? This is the equation for which condition? When amplitudes are equal, and here amplitudes are not equal. Okay? So therefore, this will be my equation of resultant amplitude, resultant intensity when amplitudes are different. Understood, no? Now here also if I take constructive interference, then cos pi should be 1, no? Okay, then how can I write this equation? So IR is equals to, okay, ma? So I1 plus I2 plus 2 root I1 root I2. I can write like this. Okay, clear, no? Or this equation I can write like this also, root I1 plus root I2 whole square. I can write like this also. So this is my resultant intensity, IR max I can call it. Root I1 whole square ఎంత అవుతుంది? I1. Root I2 whole square I2. So 2AB. So it is of the form of A plus B whole square only, no? So therefore we have written like that. Understood, Dhamma? So maximum resultant amplitude can be written like this also, root I1 plus root I2 whole square. Clear, no? Now similarly destructive interference. First you take amplitude. So R square is equals to A square plus B square plus 2AB cos pi. Destructive means cos pi should be minimum, no? And what is the minimum value of cos pi? क्या की बोल डाल लो जी, जरा सोचो जी. 0 से भी जरा कम है, -1 भी एक ऑप्शन है, అది కూడా ఒక ఆప్షన్ ఇది తెలుసా? cos pi is equal to -1. cos value varies from +1 to -1, no? Sin value also varies from +1 to -1. So minimum value is -1. So therefore what is the equation I can write? R square is equals to A square plus B square minus 2AB. Clear, no? So this is of which format? This is of the form of R square is equals to A minus B whole square. So therefore R is equals to A minus B. This is my answer. Okay, ma? So what do you understand by A minus B? Just you have to subtract the amplitudes. Amplitudes ne meeru subtract chesthe chalu. In which condition? For destructive interference. See ma, for constructive what we have done? We have added. Destructive, just you subtract them, you will get the resultant amplitude. That is called superposition principle, no? Clear, no? Now you take intensity. So IR, resultant intensity, is equals to, so I1 plus I2 plus 2 root I1 I2 cos pi. And here also cos pi value should be how much, ma? -1. So therefore IR is equals to I1 plus I2 minus 2 root I1 I2. This equation how can I write? IR is equals to root I1 plus minus root I2 minus root I2 whole square. I can write like this, and this is minimum intensity. Okay, ma? So maximum intensity is root I1 plus root I2 whole square, plus here you will get minimum intensity is root I1 minus root I2 whole square. Is my minimum intensity. Okay, that's it. ఇన్ని క్యాలిక్యులేషన్స్ మీరు గుర్తుపెట్టుకోవాలి. సిమ్. So this calculations already we have done. No? Maximum resultant intensity is root I1 plus root I2 whole square, and minimum intensity is root I1 minus root I2 whole square, and this also we have done. So a plus b whole square divided by a minus b whole square. Clear, ma? Similarly, how intensity is directly proportional to width of the slit, ma? See in the screen we make slits, no holes, no? So depending on its width also, diameter also, intensity depends upon. Okay, so intensity is directly proportional to width. If width increases, more light will enter and more bright the screen will be. Okay, so intensity is directly proportional to width. So I1 by I2 is equals to W1 by W2, and intensity is directly proportional to amplitude square. No? We are not talking about resultant values here. I am talking about intensity of first light, intensity of second light. So I1 by I2 is equals to A square divided by B square. So these are the equations which we have on intensity and amplitude. Okay, that's it. Okay, ma? So see, so distance between slits and screen is 1 meter. It means it is capital D, no, ma? Capital D is 1 meter. And distance between slits means small d. Small d is 5 mm, so 5 into 10 power minus 3 meter. Separation of successive maxima, sima. So this is one bright fringe, this is another bright fringe. Okay, so distance between two bright fringes is nothing but beta. This is what we have studied, no? So distance between two successive maximum is nothing but beta, he is asking. So therefore that beta value is how much? 0.1092 into 10 power minus 3 meter. Okay, ma? Then calculate the wavelength of light used. Lambda value we are supposed to calculate. So just direct substitution of the equation. So beta is equals to lambda d by d. Okay, ma? So therefore lambda value is how much? Lambda is equals to beta into small d divided by capital D. So beta value is how much? 0.1092 into 10 power minus 3 multiplied by d is how much? 5 into 10 power minus 3 divided by capital D is 1 meter. So just to do this calculation, that is the required amount of wavelength. So answer is 5460 angstrom. Okay, ma? 5460 angstrom, or 5460 into 10 power minus 10 meters. That is the width of the fringes, wavelength of light to be used. Okay, see here. So in Young's double slit experiment using sodium lamp means this much amount of wavelength. So on the screen 62 fringes are obtained. It means this is a screen, ma? So length of the screen will be constant, no? Length of the screen will be how much? Length will be constant. Clear, no? So on this screen, if I use this much amount of wavelength, how many fringes I am getting? 62 fringes I am getting. Are you able to understand, ma? Then instead of this light, I am using another light of wavelength 4358 angstroms. Then how many fringes I will get? That is the question. So can you say how can I solve it? How can I solve it? Huh? Length is a constant, no? So can I write total length of the screen is equal to how many fringes I got initially? 62 into lambda d by d. Can I write like this? So total 62 fringes will fill the total screen, no? So this is each fringe. How many fringes? 62. So 62 fringes will be equal to length of the screen. Clear now? Now same can be written as if I use this much wavelength. Instead of using this wavelength, if I use that wavelength, how many fringes I will get? I don't know. Let it be n. How many fringes I get? I don't know. No, let it be n. N multiplied by same formula, lambda d by d. But lambda value is changing, no? So I will write it as lambda dash. Okay, ma? And what about d? It is a constant. What about small d? It is also a constant. Clear, no? So d by d get cancelled. So what is the answer I got? So I want n value only, no? So n is equals to 62 into lambda divided by lambda dash. So 62 into what is the initial wavelength? Initial wavelength is 5893 divided by final wavelength is 4358. Okay? If you do this calculation, I will get 84 to be my answer. 84 fringes I will get. Are you able to understand? मटर कर डालते तुम्हारा वो दोनों ऊपर है तो क्या 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 आ जाता है जी आंसर तुम्हें तुम्हारे घर में गए सर के बाजू घर में गए सब सीमा. So in Young's double slit experiment, interval between two slits is 0.2 mm. What is meant by interval between two slits ma? Small d. See ma, these are two slits, no? So this distance is called as a d. This distance is called small d. Clear, no? And the distance of slits from the screen is called capital D. This is capital D. So small d, how much he gave? Small d is equals to 0.2 mm means 0.2 into 10 power minus 3 meters. Clear, no? And what is the wavelength of light used? So 6000 multiplied by 10 power minus 10 meters. Interference fringes are observed on a screen of distance. What is the capital D distance of screen is how much ma? It is 0.8 meter. So this is the data which is given. Okay. Now the question is, he is asking distance of second dark fringe from central fringe. Value bolo. Value bolo ji, formula bolo. Answer na comment. Beta plus beta by 2. That's it. Clear? Sima. Sima, first dark fringe will be at which distance? Poddan class lo chadinam kada. First dark fringe will be at what distance? Beta by 2. Second dark fringe? Another beta. Clear, no? So, second dark fringe will be at a distance of how much a distance? Beta plus beta by 2. So, this is what I want. That's it. So, it is how much ma? 3 beta divided by 2. And beta value already we know, no? So, beta value is how much? 3 by 2 into lambda d by d. That's it. So, substitute all the values. That is my answer. Inte na kavalsin. Answer kon puchinje tumna? Yeah, my puchas. Clear? वोच ने मैं पूछा सो फार्मूला क्या जी जब से वोच ने आज पूछता हूँ सो उनको वो ऐसा कौन सी तुम्हारा सी द सेकंड क्वेश्चन डिस्टेंस ऑफ सेकंड डार्क फ्रिंज फ्रॉम सेंट्रल फ्रिंज फर्स्ट डार्क फ्रिंज विल बी बीटा सेकंड डार्क फ्रिंज 2 beta that's it so 2 into lambda d by t that's it this is my answer okay ma so values I will write down so 0.360 centimeter कर लेना वॉच नहीं तुम नया सो और सेंटीमीटर्स में 0.36 है तो मीटर्स में तुम्हारा 360 कैसा है जी 0.480 centimeters okay ma that is the respective positions of so this is the second dark fringe and this is the second bright fringe understood no okay ma so see this question slit widths are in the ratio of 9:1 so W1 by W2 this is in the ratio of 9:1 this is the question no then what he is asking us to find out the ratio of I max divided by I minimum this is what he is asking clear no see my in the notes what we have written slit widths is directly proportional to intensity of individual lights also no? And it is equals to A by B whole square also. These are the equations which we have written. Gurtunna evi equations. Slit widths are in the ratio of intensities and intensity is directly proportional to amplitude square. So this is the intensity of first wave, this is the intensity of second wave. Okay? Now, so therefore, what is the ratio I got? 9:1. Now, I max by I minimum ratio also we have, Nama. What is that? a plus b whole square divided by a minus b whole square. This ratio we have, no? Okay. So do one thing, divide completely by b by b. If I multiply by b, nothing will happen, no? Okay. So therefore this equation converts into what? This equation converts in the form of a by b, because I know the value of a by b only. A by b value is 3:1, no? Are you able to understand, ma? So therefore how can I write this one? A by b plus 1 whole square divided by a by b minus 1 whole square, that's all. A by b is a by b. B by b 1. Clear, no? Similarly, this b becomes denominator to denominator for a minus b. అర్థమవుతుంది కదా? This b goes into the denominator of this one. This b goes into the denominator of denominator. Denominator to denominator is numerator. Are you able to understand, ma? శత్రువుకి శత్రువు మనకు మిత్రుడు అనమాట. అట్లా ఇది కూడా. Okay. So a by b value already we have calculated, no? How much? So a by b value is 3:1. So substitute here. So therefore it is 3 by 1. So 3 plus 1 divided by 3 minus 1 whole square. So 4 square divided by 2 square. So 16 divided by 4 is 4. 4:1. That is my answer. Clear, no? అసలు ఏమన్నా ఉందా క్యాలిక్యులేషను? Sima. So in Young's double slit experiment, what is the wavelength of light used? It is 6000 angstroms. Clear? Fringe width is 2 mm. So that is beta value is how much? 2 mm. So 2 into 10 power minus 3 meters. So what will be the fringe width? That is beta dash. I want to find out. If entire apparatus is immersed in a liquid of refractive index 1.33. Clear, ma? So we are taking an apparatus of what you call Young's double slit experiment, and we are immersing this one completely in some water, in some liquid of some refractive index. Are you able to understand, ma? Okay. Then what will be the fringe width? Actual fringe width is how much? 2 into 10 power minus 3 meter. That is the question. Okay. Actually, what is beta value? Beta is equals to lambda d by d, no? So if I immerse this one in water, which parameters will change? Can you say? Only lambda will change. What is a small d? Distance between the slits, that will not change. Capital D, distance between the slits and the screen, that also does not change. If anything changes, that is lambda. Now how can you say how lambda changes? So beta dash, how can I write, ma? I can write lambda dash d by d, no? I can write like this. Now anybody, can you say how can I calculate lambda dash when it is immersed in a refractive index of liquid 1.33? Chappandi. Sima, we have a parameter called refractive index, no? Refractive index of a material, how can I write? Speed of light in vacuum divided by speed of light in medium. Do you remember this one? Refractive index of a material, kida the formula? Clear, no? So speed of light in vacuum divided by speed of light in particular medium. That comparison itself is called as refractive index of a material. Okay. So speed, how can I write? Speed, I can write it as c by Vm. I can write like this, no? What is c? Speed of light in vacuum. Vm, speed of light in medium. So what is the formula to calculate speed? V is equals to nu lambda, no? This is the formula. Okay. So V nu lambda divided by nu lambda dash. Now what is lambda? What is lambda dash? Lambda is the wavelength of light when light is present in vacuum. Lambda dash is the wavelength of light when it is present in medium. Okay. Now what is new? Frequency. Can you say how frequency changes when light enters into another medium? వేరే మీడియంలోకి లైట్ ఎంటర్ అయినప్పుడు ఫ్రీక్వెన్సీ ఎలా మారుతుంది? రే ఆప్టిక్స్లో చెప్పినాను ఆ పాయింట్ మీకు నేను. तुम्हें ऐसे आंसर बोलेगा तो चल जा तुझे भाई. मामूल से कर सकते हैं, ऐसा करना. फ्रीक्वेंसी कैसा बदलता है जी का? तो बेंड होता है नहीं सीधा जाता है गति का जी. फ्रीक्वेंसी कैसा चेंज होता है वो क्वेश्चन. हाउ फ्रीक्वेंसी चेंजेस? Frequency never changes. That's what we have discussed in ray optics, no? Frequency always depends on source ma. Frequency ఎవరిపైన డిపెండ్ అవుతుంది? సోర్స్ పైన. And it never changes when it enters into medium. Are you able to understand? So therefore what I write here, frequency never changes. This point always you should remember ma. In ray optics also it is very important. Clear? So therefore if it doesn't change, I can cancel it, no? So therefore what is lambda dash? Lambda dash is equals to lambda by mu. Okay. Now just substitute in the what you called required equation. So beta dash is equals to, instead of lambda dash what I can write? Lambda by mu multiplied by d by d. Okay. So this can be written as lambda d by d divided by mu. I can write like this, no? And what is lambda d by d? Lambda d by d is nothing but beta. Its value is already given, no? So substitute. So therefore it is 2 into 10 power minus 3 divided by refractive index is how much? 1.33. So just to do this calculation, I will get the new fringe width when liquid is immersed in some liquid. Are you able to understand, ma? And what is the answer? You will get 6666 1.5 millimeter. Okay, ma? So 1.5 mm. Previously it was 2 mm, no? Now it is 1.5 mm. That's it. Have you understood? Huh? Very, very, very important problem. Huh? There is a probability that question can be asked from this one also. Okay? Okay, ma? So, two coherent sources of intensity ratio 100:1 interfere. Okay, ma? It means I1 by I2 ratio he is asking, no? I1 by I2 ratio is 100/1. So I1 by I2 is nothing but A by B whole square, no? Ma? So therefore A by B is how much? A by B is 10/1. 10:1. Clear, no? Now just ratio of maxima to minimum interference pattern. Intensity he is asking at maximum and minimum. So I max divided by I minimum is how much? A plus B whole square divided by A minus B whole square. Clear, no? So this can be written as A by B plus 1 divided by A by B minus 1 whole square. Clear, no? So therefore A by B value 10. 10 plus 1 whole square divided by 10 minus 1 whole square. So 11 square divided by 9 square. Okay, ma? So 121 divided by 81. That is my answer. Okay. So let us try by another method. So I max divided by I minimum is equals to root I1 plus root I2 divided by root I1 minus root I2 whole square. This formula also we have, no? Ma? So this one how can I do? Just divide this one by root I2. Root I2 by root I2. Then same equation I can write like this also. So root of I1 by I2 plus 1 divided by root of I1 divided by I2 minus 1. Okay? And whole square. Clear? So square undara malli? Square is there. So root I1 by I2. I1 by I2 is 100 by 1. Root I1 by I2, 10 by 1. So therefore 10 plus 1 divided by 10 minus 1 whole square. Okay, ma? So 11 square divided by 9 square. So 121 divided by 81. You can do like this also. ऐसा कर सकते. Okay? Sima. So ratio of intensities at maxima and minima in the interference pattern is 25:9. Then what is the ratio of slit widths? Okay, ma? So W1 by W2, this is what he is asking. This is equals to I1 by I2. This is equals to A by B whole square also. This we don't know. Now what he is giving I max divided by I minimum. So I max divided by I minimum is equals to 25 by 9. So this can also be written as A by B plus 1 whole square divided by A by B minus 1 whole square. That's all, no? So therefore A by B plus 1 divided by A by B minus 1 can be written as root of 25 by 5 by 3. Clear? So if you solve this one, then you will get A by B. Once you get A by B, you just square it. That is the ratio of the slit widths. इट्ला చేస్తున్నారా? हाँ तक करें जी? कहीं हाँ तक किच करना सो? ये भी आ गया नहीं हाँ तक किच करें तो रिस्क नहीं सर कहता नहीं क्या? Okay. So therefore now do the calculation. So instead of that, let us assume this to be x1. X plus 1 by x minus 1 is equal to 5 by 3. For simple of calculations, so 3x plus 3 is equals to 5x minus 5. So 2x is equals to 8. So x is equal to 4. Clear, Nama? So therefore A by B value is equal to x is equal to how much? It is 4. So therefore W1 by W2 is equals to 4 whole square. So it is 16. So 16 is to 1. That is our answer. Okay? Okay. So see this problem. So two sources of intensities, I and 4i. It means I1 value is IMA, I2 value is 4i. So they are used in an interference experiment. So obtain intensities at points where there is a phase difference of 1, 2, 3. So for obtain intensities means what? Resultant intensity only he is asking. So this is the intensity of first wave, intensity of second wave. When these two interfere, I want the resultant intensity. So what is the equation to calculate resultant intensity? IR is equals to I1 plus I2 plus 2 root I1 I2 cos pi. That's all, no? So cos pi is phase difference, no? So what is the first one he is asking? 0. Two into root of I1 I2. Subbarao, root I1 into root I2 can also be written like this also. That cancel out there. Cancel over that. Okay? Tantad veda but pare. Sima. So IR is equals to first angle you take theta is equals to 0 degrees. So I plus 4i plus 2 into 4i plus I, 4i into I multiplied by cos 0 value is 1. Clear, no? So that is 5i plus 2 into 2i. So it is 9i. That is our answer. Clear, no? Now remaining calculations I hope you can do. Now for second angle, cos pi by 2 will be how much? 0. Cos 90 is 0, no? For third one, cos pi value is how much? -1. So substitute these values instead of cos pi, you will get the required answers. That's it. 5 pi. 5 pi is the answer for second option, 5i. And for third one, the answer is I. When angle is pi, intensity is I. For this one it is 5i. For this one it is 9. Okay. So that is the end of topic called Hygiene's principle.